Hi, my name is Myles Koch, and I'm the project leader for the Motorcycle CAN bus team. My partners for this project have been Allee, Philip Schoeman, and Taylor Nguyen. Our project was to create a microcontroller that would interface with a motorcycle and control its accessories such as extra lights or high-powered horns. Throughout this process, we have learned valuable project design skills along with skills in facing adversity. From start to finish, there have been many times in which we have had to adapt to changes based on new information to fulfill our scope of work for this project. I will now hand it off to Eric to discuss some of the design aspects of our project.
To meet our design goals, the core features of our device are a TI CAN transceiver, which will allow us to connect to the motorcycle's CAN bus, and a TI MSP430 series microprocessor to control the functions of the device. The CAN transceiver will operate at our required 13.4 volts and supply of 5 volts to a low dropout regulator that delivers 3.3 volts to the MCU. The chosen MSP430 has JTAG and SPI-by-wire connectivity for programming, a serial peripheral interface for communication with the CAN transceiver, PWM generators, and general-purpose I/O ports. These I/O ports trigger the gates of our N-type MOSFETs, which allow power to flow through our connected accessories. Next, I'll turn it over to Philip.
Thanks, Eric. Our aim is to increase the safety of the rider by providing a way to control accessories without losing focus. Instead of adding additional buttons or other controls, we have the rider use factory controls that they'd already be familiar with. This allows the rider to turn on accessories without having to search for a new control. Due to the disproportional high percentage of motorcycle accidents that are fatal, being able to stay focused is key. From NHTSA 2017 data on motorcycle traffic, motorcycles made up only 3% of all registered vehicles on the road and 0.6% of all miles driven. They also have a 600% fatality rate per vehicle and a 2,700% fatality rate per miles driven when compared to a passenger car. Of the fatal accidents involving a motorcycle and another vehicle, 72% were from the front of the motorcycle and 42% were from a car turning left into a motorcycle. So we aim to increase the focus and visibility of the rider by allowing them to turn on accessories without having to lose focus off the road. With that, I will now pass it off to Taylor.
For our results, the board works performs to our expectations. This is confirmed by our testing of the power, the TCAN, the MCU, and the accessory power. So in conclusion, the group has successfully produced a microcontroller that can control power to the accessories. This validates our circuit design, the soldering of the components used. This also confirms that code produced works as expected and was successfully integrated with our hardware. This concludes our presentation, and we want to thank you for watching this today.